Hey guys, just an answer for question 6A and B of the A1 worksheet. Okay, so for A, we've got a rational function here that looks something like this. And we're trying to find the slope at x equals 1. So just from the graph, right away, I can tell it's probably going to be a negative slope. It looks like it is. So I can do a very simple method. I can do a method that a grade 9 could almost do. And that is, I could just pick a point on my graph, like x equals 1. Let's figure out what y equals. So 8 divided by 3 plus 1 would be 2. So I've got a point at 1, 2, which is that point. That's where I want to find the tangent line to. But then I could also just pick a point that's really close to 1. So like 1.0001. And then I could find the y value at that point. So if I subbed that in and I got 8 divided by 4.0001, I would get 1.99995 and some other decimals. Okay, so now I've got 2 points. So I've got this point and this point. So I could actually just do change in y divided by change in x, like you learned in grade 9. y2 minus y1 over x2 minus x1. So that's the simplest way. So like 2 minus 1.99995 divided by 1 minus 1.0001. And that would equal 5 divided by, perfect, negative 0.5. So that's one way you can do that question. You can just pick two really close together values and find the slope. Or let me show a trickier method with B. So with B, you could do the exact same thing. Like you could use x equals 16 because that's where you want to find the tangent line to. And you could also do a really close value to 16, like 16.0001 or 15.999. So that is a method for finding instantaneous rate of change, which is like the slope of the tangent to each curve. Or you can do the difference quotient like we talked about in class. In class, on a video. So the difference quotient was where you basically do the same thing you're doing over here, like picking two really close together values, but you're just calling that difference in values h. So you're saying find the slope at those 2 points, which is essentially what we did here. Like in this question, our h value is 0.0001, right? It's the difference between the two x values. So we're just, h is that interval between 2 points on our graph, and we want that h value to be super small. So you could actually just sub in x plus h for every x point here. So this would become, so f of x plus h would be root x plus h minus 7 minus f of x, which is root x minus 7 divided by h. And you could simplify this a lot more using the difference of squares conjugate thing that I talked about in one of those videos. Or you could just straight sub in the 16 and a really small value for h. Like you could actually just sub in an h value of 0.0001 or something like that. So I'm not going to show that because I think I did it in the question. So like actually just subbing in h values, it's like the same way I did it over here. So that's continued on the worksheet. I think you know how to do that one. Or you could do the limits way. So I talked about limits as h go to 0. So that's just like, that's what we're going to be getting into. This is where instead of having a really small interval, we're actually just finding the slope at one specific point. So we would do just like what we have in our difference quotient, minus root x minus 7 divided by h. And we want to be able to sub h equals 0 in. But we can't because it's in the denominator. So what we have to do is, this is the weird part of the question, we have to multiply the numerator by the conjugate of itself because we don't want h to be in the denominator. Okay, I'm sorry. So what I did was I subbed in 16 for x first because it just made it easier algebraically. In the future we won't, but for now I'm going to do it. Okay, so just to neaten things up a little, that reduces to 9 plus h, and this is just root 9, which, you know what, let's just write it as 3 over h. Okay, so now we got to multiply it by the conjugate. So we got to multiply the top by root 9 plus h plus 3, and we got to multiply the bottom by root 9 plus h plus 3. So that's just because we can't leave that h on the bottom because we want to eventually sub in 0, but right now we can't because then the denominator will be 0. So often when you have a square root, you can create a difference of squares thing that actually gets rid of the square root on the top, and it ends up simplifying everything really nicely. So if we were to multiply the numerators together, check out the video that I made on this if you don't understand that. But if we multiply them together, it's a difference of squares, right? So like x plus 1, x minus 1 expands to x squared minus 1. So I'm going to use my knowledge of that to know that this will expand to root 9 plus h squared minus 3 squared over h, which will then reduce to root 9 plus h squared is just 9 plus h minus 9 over, oh, it wouldn't be over h, sorry, I forgot to multiply it by the rest of the stuff, 9 plus h plus 3. So you have h, root 9 plus h plus 3. Okay, then the 9s are going to go away, 9 minus 9 is nothing, and the h's are actually going to cancel out as well. So we're just left with the limit as h goes to 0 of 1 over root 9 plus h plus 3. And then we can sub a 0 in for h, bringing us to 1 over 6. If that's 0, then root 9 is 3 plus 3. I'm so sorry, that was really fast. So that's tricky. I didn't really mean to get to that this week, but it's not horrible that you got introduced to it. But just so you know, this method over here is totally acceptable and will work for any function. Also, the difference quotient, this guy right here, it's the same thing as this, but it just kind of saves you a step because you can just sub in, 0.001, sub in 16 for x, and you just solve it. And you'll get 1 over 6, but you'll probably get 0.166666. Or you can do the limits way. And the limits way is what we're all going to eventually be doing, but not yet. Okay, I hope that somewhat helped.